k things will always occur. Therefore, from total r things, those are to be taken out of n things. We first take k things from those r things and permute 60. Here I have not used the formula of NPR. Now with the help of that formula, using NPR formula, good morning, welcome to my maths class, welcome to btosacademy. Today I shall continue the chapter or topic permutation and combination. In the last episode I deduced NPR is equal to product of n minus 1, n minus 2, n minus r plus 1. If I use the bar bracket, then n minus under bar bracket r minus 1, which is equal to factorial n by factorial n minus r. The meaning is that out of n different articles, things or objects, taking r things or r objects at a time, total number of arrangements of those r articles, that is equal to this. And I mentioned there r is less than equal to n. Now, as corollary, if n equal to r, means we are taking all the articles of given n different articles and arrange, then total number of arrangements will be as per this expression. First of all, npn, that will be equal to n into n minus 1 into n minus 2 into n minus 3, 3 into 2 into 1. Putting r equal to n here, after simplification we will get value is 1, and before that the factor will be 2, before that the factor will be 3, like this, finally this, and this is as per definition of factorial symbol, this is factorial n. Now if I use this form also, npn is equal to factorial n by factorial n minus n, that is factorial n by factorial 0. Now npn is equal to factorial n as per this expression, and npn is equal to as per this factorial n by factorial 0. Therefore factorial n by factorial 0 is equal to factorial n. Now this will be hold if factorial 0 is 1. And while I discussed factorial symbol, factorial n is equal to, it is discussed that product of successive numbers starting from 1 up to n. We have not defined there factorial 0, and I mentioned there factorial 0 is taken to be 1. Now this is the situation where we must take or we must accept that factorial 0 equal to 1. Now, let me discuss the next issue, that is, in this theory, n articles are taken to be different. Now, from those n articles, we are taking r articles at a time and arrange. Now, if we take or if it is permissible that we can take an article any number of times, that means repetition is allowed, then what will be the number of arrangements or number of permutation? I call it this is actually happened when digits are considered. Say 4 digits are given and we are to form 3-digit, 2-digit or 4-digit numbers. If repetition is allowed, and that is quite essential. If it is not mentioned that repetition is not allowed, we have to consider repetition is allowed. Then I discuss the number of arrangements. In different articles, objects, things, are articles, are taken altogether we can explain that by considering the matter that there are holes. This is first one, this is second one, this is rth hole, and we are given n different marbles as discussed initially. Now, first hole can be filled in how many ways? N ways, no problem. Now, since repetition is allowed, therefore, second hole also can be filled in n ways. Now, filling the first hole in one way, number of ways filling the second hole is n. Therefore, filling the first hole n number of ways, total number of ways of filling the first and second holes will be n into n. first and second holes. Repetition is allowed. Remember this thing. Now, if we proceed in this way, then we can easily say that our holes can be filled totally in n into n into n. This is rth n. That means finally n to the power r wedge. Therefore, it is clear that if repetition is allowed, r holes can be filled by n different articles, or we say simply n articles in n to the power r wedge. Already I have told that this is used in case of digits. I explain with the help of an example. Five digits 1, 2, 3, 4, 5 given. Then how many 3-digit numbers can be formed? 3-digit numbers. First case, no repeat. If repetition is not allowed, then we can explain like this. 3-digit numbers, we can draw rounds, 3 rounds like this. The first digit can be filled in how many ways? 5 ways. Since there are 5 digits, repetition is not allowed. Therefore, after filling the first place, the second one can be filled in by remaining 4 digits in how many ways? 4 ways. After that, third place is there. This third place can be filled in how many ways? Already we have used 2 digits. Repetition is not allowed. Therefore, that third place can be filled in 3 ways. Therefore, filling the first place in 1 way, second place can be filled in 4 ways. Therefore, filling the first place in 5 ways, total number of filling will be how many? 5 into 4 ways. Now, filling the first 2 holes in 1 way, the third place can be filled in 3 ways. Therefore, filling the first 2 holes in 5 into 4, that means 20 ways, total number of ways of filling will be filling three places is equal to 5 into 4 into 3. Now, if we use the symbol in pair, it will be 5 E3. You can calculate yourself. With the help of logic, we can solve this problem in this way. And if we use the theory is that out of n different things, taking r things at a time, total number of arrangement is npr, where n equal to 5, r equal to 3. Therefore, 5p3. And if we calculate in this way, result will be 60 ways. Also in this way, 60 ways. Now, the second case. Repetition is allowed. First place can be filled in five ways. First place can be filled in 5 ways. Since repetition is allowed, second place is also can be filled in 5 ways, and third place also can be filled in 5 ways. Remember this, repetition is allowed. Therefore, total number of arrangement will be five into 5 into 5, that is 5 cube, that is 125 ways. Now, if we apply this theory, total number of arrangements will be n to the power r, that is 5 cube, that is also 125. Therefore, I have discussed from this original theory NPR, total number of arrangements in case of repetition as well as in case of no repeat case. Now we are going to find the number of permutations or arrangements of n things when the things are not all different. We started when n things are different from each other, but where n things are not all different. I am going to discuss by I am trying here to make you understand the students uh, total number of things n of which p things are of one kind identical. Q things are also identical of another kind. And R things are there, they are also of same kind of another kind. And others are all different. Now we take all these n things and what will be the number of arrangements? If, or I take start like this, let number of permutations be x. Now listen carefully. These three kinds of things of particular kinds, we replace those. How? First, p things of same kind are replaced by different p things. Say things be like this: a1, a2, a3, a2. Follow that. P things have been replaced by different p things which are a1, a2, a3, ap. That means p things of same kind here are now different. Now if x be the number of arrangements of permutations, then for each permutation these p things are there. Now if we replace those p things by these, then each will give x number of permutations. Now p things, when considered different, total number of permutation will be x into factorial p. Why factorial p? Because these different a's, ai's rather, can permute in themselves factorial p ways, and for each permutation, number of permutation is x. Therefore, if we arrange those p different things or articles in factorial p ways, total number of arrangements will be x into p factorial. Next, we replace these q things, say by b1, b2, b3, bq. Then for each number of permutation is this. Therefore, for q things, q articles, total number of permutation will be in that case x into factorial p into factorial q. Then the next r things which are of same kind are replaced by, say, c1, c2, c3, cr. Then for one thing, number of arrangements is this one. Therefore, R things, for R things, total number of permutation will be in that case this one, x into factorial p into factorial p into factorial r. Now what we find, and these remaining things are different from each other. Now after replacing these p things of same kind, q things of same kind, another type, and r things of another type, after replacement by different things, what we find, all n things are different. That means we are taking here are different articles or are different things or are different objects. Now if we take all these are things together, total number of permutation will be how many? Factorial n. Therefore, this product is equal to factorial n. Students, you follow this. Very interesting. P things, Q things, R things. Out of n things, P things are of same kind, Q things are of another same kind, R things are also of another same kind. Total number of things are. Now, what will be the number of permutation? What we have done? First, P things are replaced by A1, A2, A3, AP, P numbers of different AIs, and these Q things are replaced by B1, B2, B3, BQ, and these R things are replaced by C1, C2, C3, CR, and all are different. After these replacements, all n things are different, and it is discussed that after replacement these things, if the original number of permutation be x, then this will be the number of permutation of number of arrangements. And when n things are different, then we know number of permutation is npn, which when simplified is factorial n. Therefore, these two are equal. From it, we get x equal to factorial n divided by factorial p into factorial q into factorial r. Thus, when things are not different, then number of permutation is this one. Here, the word proportion is given, and we have to find the number of permutations if all letters are taken together. First of all, we note that there are two P's, three O's, and two R's. That means not all letters are different. First of all, number of letters in the word count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. out of which there are two p's two r's and three O's. You see, two p's, two r's and three O's, and other are different. Now already we have learned, if n things are given, of which p things are of one kind, q things are of another kind, of course identical, and r things are of another kind, identical, then total number of permutation taking all n things together will be factorial n divided by factorial p into factorial q into factorial r. Here we shall apply that. Therefore, number of permutation taking all 10 letters of the given word is equal to, you can mention here, this is n, this is p, this is q, and this is r. Factorial n by factorial p into factorial q into factorial r, that is equal to factorial 10 by factorial 2 into factorial 2 into factorial 3. Now you calculate this. If calculator is allowed, you can use the calculator or follow 10 into 9 into 8 into 7 into 6 into 5 into 4 into factorial 3, 2 into 2 into factorial 3, which are cancelled, then final result will be 1 5 1 2 0 0. I request all my students to check. Sometimes I commit counting mistakes. Actually, in the earlier episode, I committed one mistake. I think you have noted that. Those students were following. And the most important thing is that I am trying to make you understand how to solve the given problem. What is the matter while you are solving the problem? Therefore, that is very important. And I always request my students, while I take classes also, offline classes, that you always check the results or calculation your teacher is doing. I have written here the answer from checking the answer from the book. The answer is this. And one thing I mentioned here, sometimes I see online classes and concerned teacher announces that uh, he is going to show the students some tricks so that they can solve very quickly, very easily. Mathematics is not that subject. According to my view, mathematics is not subject. I have no such magic stick. Remember this. Be careful. You are to be careful, sincere, hardworking to learn any subject. While you are learning mathematics or any science subject, you must be very careful. You must be dedicated, sincere. Then you can improve in the subject. Okay. Now let me discuss next thing. Next, restricted permutations. Now, in some problems of permutations, restrictions will be given. I am going to discuss one by one. The first restricted permutation is n different things are there. You are taking r things and permute. Now the restriction is k things will not occur in any of the permutation. You are taking r things out of n things, and already it is mentioned that k things will not occur. That means we first delete those k things from the total, then out of those remaining n minus k things we take r things and permute. K things will not occur. Therefore, out of n minus k things, r things are to be considered. Therefore, total number of permutation here, of course, k is less than r. K is less than r. Next one is to determine number of permutations of n different things. N different things and the restriction is k particular things will always occur. In the first case, k things will not occur, and in this case, k things will always occur. R things are to be taken. Then total number of permutation. First of all, k things will always occur. Therefore, from total R things, those are to be taken out of n things. We first take k things from those R things and permute. Then permutation will be R P K. Now k things already we have taken k things out of R things. Then remaining things is n minus k. From that n minus k, already we have taken k things. Since k things will always occur, if we consider like this, R places to be filled. R places are to be filled, of which k things or k places, k things rather, will always occur. Then if we fill k places out of R places, of course k is less than R here, then out of n minus k remaining things, we have to take R minus k, because total number of things to be taken are R minus k plus k, that is equal to R. Try to understand, n different things are there, and of which k things will always occur. Keeping that in mind, we can say like this: out of R gaps or R places, we first fill k places, then R minus k things are to be taken out of remaining n minus k things. Therefore, total number of permutation will be this way: RPK into k minus k P R minus k. I just rewrite. Because these k things which occupies or which will occur always can permute in themselves in factorial k ways. Therefore, permutation will be for those k things RPK into n minus k things are there still. Therefore, out of those we have to consider R minus k things. Total number of permutation will be this. Now I am going to discuss few problems of permutations. I shall solve those sums using general concept as well as using the formula NPR. First sum: 3 families entered in a hotel while they are in a trip, and they found 5 vacant rooms are there. If each family wishes to occupy one room, then in how many ways those families can book one room for each? This is the problem. 5 vacant rooms are there. 3 families entered in the hotel. Therefore, we can solve the problem like this. Five rooms are there, 3 families. If we draw the diagram like this, first family can occupy one room in 5 ways. Now, after filling one room, 4 rooms remained. Therefore, second family can occupy in 4 ways. Out of 4 remaining rooms, and third family can occupy one room in 3 ways out of 3 remaining rooms. Therefore, now we follow. After one room occupied by first family, in one way, number of ways of occupying the second family will be 4. Therefore, total number of ways of occupying by the 2 families will be 5 into 4. Therefore, following this argument, total number of occupying the 3 families for one room for each family out of those 5 rooms of the hotel will be total number of ways those 3 families can book 3 rooms in that hotel five into 4 into 3. Here I have not used the formula of NPR. Now with the help of that formula, using NPR formula, N equal to 5, total number of rooms in the hotel 5, 3 rooms are to be booked. Therefore, total number of ways of booking is equal to NPR, that is 5 P 3. And if we calculate, it will be 5 into 4 into 3 into 2 by 2. Now, my suggestion to students, learners, you can solve any of these two ways. When the problem will be a bit complicated, use the formula NPR. Otherwise, using the statement, you can solve this. Now, second sum is what that I must have. In how many ways can a vowel, a consonant, and a digit be chosen out of 26 letters of the English alphabet and the 10 digits? I first show in the rough space vowel, first vowel, then consonant, then digit. A vowel, a consonant, and a digit be chosen out of 26 letters. Letters of English alphabet. Then we know 5 vowels are there. Then remaining 21 consonants are there, and digits are 10. Starting from 0, 1, 2, 9. Now we can solve this sum like this. Out of 5 vowels, we can take one vowel in how many ways? One vowel can be taken in 5 ways. Then out of 21 consonants, one can be taken in how many ways? 21 ways. Then a digit, one digit can be taken in 10 ways. Now for taking one vowel in one way, one consonant can be taken in 21 ways. Therefore, taking any of the 5 vowels, total number of ways of taking one vowel and one consonant will be 5 into 21 ways. Now, following the same argument, total number of taking one vowel, one consonant and one digit will be total number of ways of taking one vowel, one consonant and one digit is equal to 5 into 21 into 10. Now, if we use Ampere formula using P1 for vowel into 21 P1 into 10 P1, the value will be same. Try to understand, students. Now this problem, two sets are given, A, B. A has members 3, 4, 5, 6. B has members 0, 1, 2. Now we have to find number of different ordered pairs, of which first component will be a member of set A, second component will be a member of set B. I explain like this. If we consider one member from set A, number of permutations of or the number of ordered pairs, those can be formed having the second component from set B will be how many? 3, as there are 3 members in set B. Ordered pairs having 3 as first component will be 3, 0, 3, 1, 3, 2, 3 in numbers. Follow this. If I take the first member of set A and form the ordered pairs so that 3 occupies the first place, then number of ordered pairs will be 3, as there are 3 members in set B. Therefore, for one member belonging to set A, three order pairs can be formed. Therefore, for how many members are there? Four. Four members. Four into three order pairs can be formed, in which that is 12 order pairs can be formed. Therefore, totally 12 order pairs in each of which first component belongs to set A and second component belongs to set B. Try to understand. Here we can say we are using here fundamental principle of counting. Let us recall that if m operations can be performed, if one operation can be performed in m different ways, and following that another operation can be performed in n different ways, then totally those two operations can be performed in m into n ways. You see, we have applied that concept. Next problem. How many 4-digit numbers are there with no digit repeated or with distinct digits? That means repetition is not allowed. First I solve this one. I draw the diagram on the right side like this to have the clear idea. 4-digit numbers are to be formed. Now, number of digits namely 0, 1, 2, 3, 9. We have to form 4-digit numbers. Now, if we place 0 at the first place, then finally, ultimately, the number formed will be less than 4-digit. That is why first place cannot be occupied by 0. Here we mention that here the first place cannot be occupied by 0. Hence, first place can be occupied by any of the 9 digits 1, 2, 3, in 9 ways. Second place can be occupied by any of the digits 0 and other unused digits 0 and 8 other unused digits. Actually, while I feel the first place I have used any of these 9 digits, then we have 8 digits in hand. Then the second place can be occupied by 0 and those unused 8 digits. That means totally 9 digits. Third place can be occupied by any of the digits, any of the 8 unused digits. For the first place, I have used 1 digit out of these. Then for the second place, we have used 8 unused digits of these and 0. That means totally 9 digits. Then after filling that second place, we have still 8 unused digits. And fourth place can be filled by remaining 7 unused digits. Follow that concept. Then total number of 4-digit numbers is equal to for one number, second place can be filled in 9 ways. Therefore, for 9 choices, total number of numbers will be 9 into 9. Proceeding in this way, we can say total number of 4-digit numbers will be this one, 9 into 9 into 8 into 7. And after simplification, you will find the value will be 4536. Now, let me discuss the repetition case. Since 0 cannot occupy the first place, therefore first place can be filled, first place can be filled in 9 ways. Since repetition is allowed, for filling the second place, we have how many digits? 10 digits. Though we have filled first place by using 9 ways out of 1, 2, 3, 9. Students, try to understand. Repetition is allowed so second place can be filled in 10 ways. Similarly, third and fourth place can be filled in 10 ways each, as repetition is allowed. Know this one. Try to follow. Therefore, total number of ways or total number of 4-digit numbers is 9 into 10 into 10 into 10. Try to understand this. Very interesting one. Already I have mentioned that you got to practice a lot to have concrete idea. I suggest my students every day you practice few sums. Don't try to avoid to practice sums. In the next episode, I shall discuss more sums on permutations and combinations.